No red light.
There's a red light on this side. Oh, okay.
Gosh.
You're good.
Hey everyone, I'm Mario Loria, and this is Orchestructure. Thanks for coming. Sorry for the change of venue a little bit. Tech room is right upstairs. They don't really have a good projector facilities for that, so decided to do this. This is the third or fourth that we're doing now. We got Josh Curl here from, I call him Josh WGet, that's his handle as well. I think that's much more fitting, so bother him with that. And ask him everything about Rancher and how terrible it is and how he's working to fix it. We're in Ann Arbor Meetup, and we're actually recording for the first time thanks to George. So anyone is welcome, your friends, your coworkers. We're working on getting bigger spaces than this, so it's a little bit more space for more people to come, as all of you have been coming a lot, and it's very nice. So make sure you grab some pizza if you haven't already. Buckle your seats, and we're going to have Scott Gochi, who's kind of helping me out, orchestrate, get all this going, come and say a few words about Alpha Django. Be careful with the pizza and spilling things. Again, it's all on me. So there is water from the fridge back there, but don't steal any beer, because that's also on me. So, and if you do, let me have a sip. All right. I'm going to get Scott and make sure he's ready to go. We're ready for you. All right. Sure.
Hey everyone, I'm Scott. I worked in Alpha Django for a few years, and Alpha Django is a great consultancy that builds a lot of great startups here in Ann Arbor. I was lucky to work with them, and that's how I kind of learned programming in a major way. Steve Schwartz, the owner, has helped me a lot over the years, and now he's working on Genomenon as well. I know they're looking for developers, so if you're interested in genomic research, that's really cool data, go check out Genomenon. Also, I run the tech brewery upstairs. It's a co-working space, so if you're part of a startup or you're thinking about joining a startup and you need some shared desk space, come on up. We have a whole rich history. Duo started here. Ponguru has been here. There's been a lot of great startups that have come through, and TrueJob's there currently, but we're not quite as big as Duo yet. So, otherwise, I hope you guys enjoy the space, and I'll
Thank you very much, Scott. Yeah. We'll also be doing, we'll have some time for some announcements a little later on. Right now we have Josh Curl with his presentation. Right after Josh will be the CEO of Fly Talking. So take it away.
Cool. Thank you. So my talk is called Kubernetes Deployments, which I realized after I wrote this is kind of a bad name because there's actually a deployment construct in Kubernetes. But the focus of this talk is deploying and orchestrating Kubernetes itself. So it's not so much like the concept within Kubernetes, but all the components that make up Kubernetes. So a little about me. I graduated from MSU about 2 years ago now. I'm currently employed at Rancher Labs. So I'm just curious, like, how many of you have heard of Rancher or played with Rancher? It's pretty good. Okay. So yeah, I guess some people already have rants about Rancher. So if you have rants, I'd be happy to hear those.
Are you sure?
Yes, I'm sure. Yeah. So in the past, I focused primarily in Rancher OS. That's kind of like what I started out on. And then about 4 or 5 months ago, I pivoted to work more in Rancher. And specifically, like lately, I've been working on Kubernetes and with the Rancher Kubernetes integration points. So I wasn't really sure, like coming into this, like what experience level everybody was at. So I have a couple of slides of just going over like the basic components that make up a Kubernetes cluster. And I'll just describe like kind of what their role is and like that kind of stuff. So roughly, like the components in Kubernetes can be broken down into like 2 different areas. So there's the ones that are worker components that are going to run on every node that you want to run your services. So these are like kubelet and kubeproxy. I'll come back to that. And then there's a group of master components where you need to run like a fixed number of these. And these are things that don't necessarily have to run in the same nodes as your user or worker components. So these include etcd, if you guys have heard of that. It's a pretty nice standalone component outside of Kubernetes. Then the API server, and then several controllers, which the details of like the individual ones aren't particularly important. Just know that like there are some that you need out of the box, and there are some like operators you can deploy after the fact. So worker nodes, like I said, like these run on each node that you want to run your services. So kubelet is like the primary agent for Kubernetes. So this is what sits on each node and actually talks to Docker and says, hey, we expect this many pods to run this node, so like please go deploy these. And then kubeproxy, which does some networking stuff. It's not like super important for this talk, just know that it's also run alongside kubelet on nodes. And then for master components, you have etcd, which the role for it in Kubernetes is basically the aggregate database. So it's like a very general purpose tool that you can use outside of Kubernetes for like many different things, but for the most part, it's using Kubernetes just to store different states. So at any time in your Kubernetes cluster, you could go back up etcd and then use that backup somewhere else and like rebuild the same cluster. The API server, it's not really a component that does a lot in itself. It's kind of just a gateway to etcd and a way of managing the data there. So it's kind of like a nice API machinery framework that doesn't do much in itself. It kind of just sits there and delegates. Well, it's not really delegating. So like when you use kubectl or some other way of accessing your cluster externally, it's actually going to be talking to the IP of the API server. And then there are controllers which talk to the API server. So in general, like, when you look at like the different like Kubernetes solutions that are out there, most of the differences are going to come in like how these master components are deployed. So there's like a little bit of complexity in like getting a kubelet and kubeproxy bootstrapped on each node, but most of the actual complexity comes in running these like one-off master components for Kubernetes. So this is kind of like a weird concept that I think is confusing at first. So you might think there's this component called scheduler in Kubernetes, and you might think its role is to go out there and like talk to kubelets and say, hey, you need to run this one, you need to run this one. But that's not actually the case though. So pretty much everything talks to API server, and that's about it. So API server is kind of like at the center of this graph where kubelet talks to API server and all the controllers talk to the API server. But you wouldn't have a controller or a scheduler actually talk to kubelet directly. So it's kind of like the API server is a spreadsheet where controllers post like which nodes should be running which pods, and then the kubelet's going to listen to that same spreadsheet and say, hey, I should be running these pods. And then also the API server is kind of like a guard for like the etcd database. It's like a management layer in front of it, so you can have like authorization policies and such. So you're not going to have any controllers that are directly talking through etcd. So where these components usually run, and this depends a lot on the management system that you're doing, but usually the split is that you're going to have a group of master nodes and a group of worker nodes. So the worker nodes are going to be running your services, you're going to be running kubelet and kubeproxy in each one, and then separate nodes you're going to have the API server and all the other things. So the scale of the services, so maybe you have like 2 API servers running or something like that. That all usually depends on like what solution you're using, like if you want to be HA or non-HA. Generally the idea is that you want to have multiple copies of everything, every Kubernetes service running. So like API server and like all the other components of it, you want those all to be redundant so that if one node, which has one API server on it, goes down, you might still have another node that's running API server so it can still handle your requests. And it's also kind of like a scale aspect to it too, where if you're running a very large cluster, you actually want to run more of these so that it can scale up. So there's like many different ways of deploying Kubernetes. It's actually kind of like one of the nice parts about it and why it's so hard to deploy. It's a very flexible system in that you can deploy it in many different ways. And it's really not very opinionated in how you run it. But unfortunately, like the downside of being flexible, it does add to a little bit of complexity. So has anybody here heard of the tutorial Kubernetes the hard way? Has anybody actually like walked through all of it and tried it?
Once.
Once.
Has anybody looked at like, the first one and then was like, wow, this is a lot of work, I'm going to skip all of this and has to go back to it? Yeah, so manually deploying Kubernetes is actually quite a pain. And manual, at least for Kubernetes the hard way, it involves quite a bit of like cloud provider specific integration. So like they'll actually deploy a GC load balancer with our API server. So it's kind of opinionated, and that's like this is one possible manual way of doing it. And then it's also doing some things where it's like each node in the master node, it's actually going and setting up like systemd units where it's running all these services, where it's not really the only way that you have to do it. And then config management, things like Puppet and Chef, like when they're deploying Kubernetes, they're kind of just automating in a similar fashion like the manual things that you see from Kubernetes the hard way. Like if you go and you look at like the playbooks and stuff for all those, like they're basically doing the same thing as the manual one. So like what I'm going to focus on mainly today are just containerized deployments of Kubernetes, which in my opinion is probably like one of the better ways to run it, just because you don't have to know nearly as much ahead of time. Like to me at least, manual deployments are quite difficult and obviously they're pretty hard to automate, but when you run things in containers, there's a lot of benefits, like the host becomes less relevant. So you don't have to interact with systemd directly or anything like that. Like what's in the host file system is not really relevant anymore, which I think is just nice because they're not mutating state on the host and everything's just running in immutable containers on the host. There are some downsides to it, and I'll talk about those in a little bit. And then the last option is hosted Kubernetes, where they're doing something behind the scenes in the nodes to provision all the services and stuff, but you don't really see it very much. So what they're doing is actually kind of irrelevant. It's kind of like a nice software as a service type solution. Great. So first, I'm just going to show off Rancher Kubernetes a little bit. So this is a containerized deployment of Kubernetes. So I'm not sure if like all of you know this, but Rancher originally, like even before like Kubernetes was 1.0, I think even open sourced, was an orchestration engine. And so like our role in the Kubernetes world began with, we're going to take our orchestration engine and we're going to deploy Kubernetes on top of that. So what we actually do is we take like the API server and all the other components, and we actually run those as containers on top of a Rancher environment. And so there's lots of really nice advantages when you use an orchestration system and containers to monitor it. So let's say you have like 3 nodes and you have 2 API servers running on separate nodes in those. Let's say one of those nodes goes down. Well, in Rancher, we have it set up so that there are actually health checks running on all the Kubernetes services. So the Rancher is going to detect, hey, this particular service is not running, and we want maybe desired scale 2. So what it'll actually do is spin up another API server on a different node. So another advantage of using containers, and in particular like an orchestration system to manage Kubernetes, is that it's very dynamic. So if things go down, they can move across nodes, and it's like you define the end state, and as long as there are enough hosts available, it's basically going to stay up, which is really nice. And so within Rancher currently, it's an etcd, orchestration, and worker split, which means you're going to have a group of nodes dedicated just for running etcd. You're going to have a group of nodes for running the Kubernetes master components, and then a group of nodes for running just user workloads. And then this is actually kind of flexible in that if you don't want to do the split, which it's kind of heavyweight, so you would need at least 3 nodes in this case. If you just want to spin up a development cluster for a group of people, and like if it goes down, it goes down, you could just spin up 2 nodes or something, and then like Rancher would just deploy all those across these nodes. Okay, so I have one environment set up right now where I have 3 hosts. So this is actually a somewhat HA Kubernetes cluster, but I'm only running one of each node in each group. So on the left here we have a node that's running with etcd. This is a host label we use to indicate that this host should only run these types of services. So you can see in the Kubernetes stack we're only running etcd, and then we're running a separate kubelet, which I can come back to later, but it's not super important. It's basically if you want to run a Kubernetes service on this node, you still can. But this is not like a general user workload. And then here you can see like all the Kubernetes services being brought up, or are brought up. And then on the last one, you can see that this is set up to run various other services. So I haven't actually deployed anything of my own yet, but if you did like kubectl run nginx, it's going to land on this third host. And then when you want to scale up this cluster, like make it real HA, you could just add another host with etcd equals true, and then Rancher would go and deploy containers to that host. So it's using Rancher as like a bootstrapping mechanism to actually deploy Kubernetes. So when you add the new host, the first thing that's going to happen is you're going to have a Rancher agent deployed to it. And then Rancher's going to see that there's a new node available and start scheduling services to it. And same thing for orchestration, and compute is more handled by Kubernetes. So when you add the node here, Kubernetes is going to see another node available for scheduling. And so when you launch new pods, it'll like rebalance them and start landing on the new hosts. Right, any questions so far?
So pods are not equal to containers. That's 2 totally different things.
Yeah, that's a whole other discussion in itself. I would say for the purposes of this talk, let's just say that pods and containers are roughly the same thing. There's like a lot of theory behind like why you might need pods. I mean, there are people who claim you don't really need them. If you look at Docker Swarm, they don't have any concept of a pod. The Rancher native orchestration handles them as kind of a hybrid of the two, where you can deploy a service which is a container, and then you can kind of tie into the container after the fact. So it's like it has a lot of benefits of the pod, but you don't have to exactly know what a pod is just to use Rancher. I can loop back around and explain like what a pod is and the difference between a pod and a container. But I'd say for the rest of the talk, just think of a pod as a container, because I kind of use them like interchangeably.
Good enough.
Or a set of containers, right?
Yeah, but then when you say a set of containers, people think it might be like a stack or something, where it's like you're deploying like multiple services that are loosely coupled. Like, you had to like dive into the whole thing. It's kind of a long discussion. I actually do like a Kubernetes training, and like, I dedicate like the first 2 slides to pods, and I basically say just think of pods as containers for now, because you're probably not even going to use them for a little while. Like the use cases for them are like a little more advanced. So it's just really confusing that the first abstraction you learn is something that's not particularly useful, it's very confusing.
I have a question.
Yeah.
This is probably a beginner question, but Kubernetes and Rancher, like in my mind, do similar stuff. Why would you want to do one? Could you put Rancher inside Kubernetes, and would that make sense or no?
Yeah, it's an interesting question. Like that's something we think about all the time. So there's definitely a lot of overlap in terms of like orchestration capability between. So I said Rancher native orchestration. We have an environment type which is called cattle, which is something we build ourselves. And then when you use a Kubernetes environment, you're kind of like not using much of that. You're only using the Rancher native orchestration to deploy Kubernetes itself. But past that point, it's all Kubernetes and native Kubernetes scheduling and such. So there's a lot of things in Rancher that actually tie to orchestration. So there's like authentication, authorization, like adding hosts, and a bunch of other stuff. And we're looking into the future, like taking some of the user experience of cattle, which most people think is actually pretty easy to use. They like the user experience of it. But there are a lot of people out there who still want to use some of the capabilities of Kubernetes, or for some reason or another, like maybe their company wants to use Kubernetes or something. So we're looking at kind of taking the same user interface and deploying it to Kubernetes. Because to some extent, like a lot of the orchestration stuff is really behind the scenes. It's really how you interact with it, how you deploy your services as a single part. Like if you're using OpenShift, I'm not sure how much you're actually interacting with Kubernetes like on a day-to-day basis. So like if you had swapped out the orchestration engine, it's probably possible. So, but yeah, there's definitely overlap. You could also use both at the same time. So if you have certain teams that prefer using cattle, it's something simpler, hopefully for developers, and then you have another environment that's for production where you prefer to use Kubernetes, you can use them in the same installation, and you can have the same admins managing both environments. But I'd say like for like a more thorough like comparison of the two, like, you might want to just like spin up two environments, just play around with them and see what the differences are. But pretty much anything you can do, most of what you can do in Kubernetes, you can do in cattle. But it's kind of just like a more straightforward user experience. So our deployment format, like rather than being like a pretty complicated YAML manifest, are very similar to Docker Compose files. So if you're somebody who's just been like playing around with Docker Run, Docker Compose, and those more basic things, it's going to be much easier to jump into cattle and learn more complicated orchestration concepts. Any other questions?
Could someone use the native Rancher tools in a setup like you have there and launch containers separate from Kubernetes?
Side by side in the same hosts?
Yeah.
You can.
Would Kubernetes see them?
Kubernetes would see them. I think it would even like react to them in terms of like scheduling and such. The other way around might not be true. It's kind of weird when you're like meshing two systems like that. Like I think we kind of like just use our orchestration up to a point and we just kind of cut it off there. Like I was saying,
use Kubernetes.
yeah, like that point, like yeah, you're basically using Kubernetes. We're looking into making it so that it's more invisible to you that the fact that you're using Kubernetes behind the fact in an environment. So maybe like you want to use kube control for some things in an environment, and then other things you want to use like a more cattle-like user experience. And then you can use those two things side by side, and then you're still deploying the Kubernetes in both. But you have the option of using like a really vanilla, raw Kubernetes experience versus like a more streamlined user experience. But it is possible to deploy side by side. I'm just not sure if it's the best idea. Okay, any other questions? Okay. Just out of curiosity, how many of you have tried Tectonic before? Or some other, like, I think Tectonic is probably the only one really using self-hosted these days. Okay, so yeah, I'm going to discuss self-hosted Kubernetes next, which it's a pretty interesting idea. It might take a minute for the concept of it to sink in if you're not familiar with it, because it's kind of like an inception and that kind of weird thing. So the idea here is that you're deploying the Kubernetes services, like the Kubernetes components, as services within Kubernetes, which is kind of a weird idea. So let me show an example of this. Okay, so other than Tectonic, you can also use kubeadmin. They have like an alpha optional self-hosted mode as well. So I just set the single node version of this just to kind of show like what this would look like. So we have a Kubernetes, single node Kubernetes cluster right here. Is this big enough? Can you guys see the right side? Yeah. I can make it bigger. Good.
I think a tad bit bigger for the I don't know if we'll get it or not, but
Exactly. So we're just interacting with the Kubernetes CLI for those of you who haven't seen it before. So this is a single node cluster. So if you look in the kube system namespace, which is where self-hosted Kubernetes deploys the Kubernetes components themselves. You can actually see that etcd, the controller manager, the scheduler, and the API server are actually deployed as pods within this cluster itself. So it's kind of a weird state where it's actually managing itself. Let me go to my next slide and try to explain like how it gets to the state. So the way that this is done is there's a temporary Kubernetes cluster that's deployed locally. So this is a non-self-hosted cluster. So it's something that's just managed locally, maybe with like systemd or something like that. And then within that temporary cluster, you actually go and you deploy a second copy of all the master components. And then at that point, you have two copies of each one running. You have one that's not self-hosted and one that's actually managed as pods. And then after that point, you kind of like cut off the first ones and you delete those. So then you have a kubelet running that's talking to Docker, managing pods, and then those pods are running the master components themselves. So even when you do this, it's kind of this weird fragile state where it's all running on one host. So if you did something like Docker kill API server, I'm pretty sure it's not going to recover from that. But then once you add a second node, you're going to have two copies of each of the the Kubernetes master components running. So you're going to have like two API servers, two schedulers, and all those things. So even if one of those goes down, there's another one running, and then it knows, because it's running as a Kubernetes service, it knows to bring that back up. This is really a pretty weird concept to explain. Let's see if there's anything that's...
Does it take a long time to bootstrap this whole setup? Is it?
I don't think it was too slow. I did with kubeadmin and init, and it didn't seem like it was that slow.
So measured in seconds or minutes or?
Probably seconds. I think it was like 15 to 30. But also that's like a one-time operation too.
Right.
So like this process where you deploy this temporary Kubernetes cluster, you only need that to basically bootstrap the first node into being self-hosted. And then once you start adding nodes, like Kubernetes is going to see those nodes being added, and then it starts scheduling services at that point, just at the regular Kubernetes way. There's no weird one-off logic after that point.
I think Chaos does that.
Does CAPS use it these days?
I think so, because I did notice when I've only done experiments with Kubernetes, and yeah, I built a cluster with Chaos on AWS, and I noticed that I could see the API server, the scheduler.
That's really interesting. I did not know Chaos switched to it. Yeah, I think like if you look at like a lot of like kubeadmin non-self-hosted, it's pretty difficult to turn those into like very dynamic systems where you can add new nodes and handle HA very easily. Like I think this is a very good direction that Kubernetes can take to like start having better out-of-the-box solutions for HA deployments. So I actually like self-hosted Kubernetes. It has a lot of the benefits that I mentioned of like Rancher, where it's like doing health checks on its own components. You can reschedule things. I can actually show you in the bootcoup project on CoreOS. Like they're the ones that kind of like took this idea from the start. And I think I didn't know Chaos was using it, but I thought they were the only ones that were actually using this in production right now. Like I know, I think the most recent version of Tectonic installer is actually using self-hosted Kubernetes and also self-hosted etcd with their etcd operator, which is also pretty cool stuff. So you can see a daemon set, which for those of you that don't know, the idea of a daemon set is you're basically going to run one container on every node in a group in your cluster. So in this case, they're actually running the kubelet as a container itself. And I still am not actually sure how they do this, because if you think about it, when you're upgrading a daemon set, it's the kubelet that's responsible for killing an old container and starting a new one. So I guess like the kubelet just brings up a new kubelet and then just knows that the old one has to be killed off. I don't know, I have to like research how they do that, but you're going to see like all the other Kubernetes services, like not just the daemon set ones, but so in this case they're running the API server as a daemon set, but they're running it, I'm sure it's kind of post label in here, so that whenever you add, like let's say a new node to Kubernetes with the label master equals true or something like that, then they're going to see that if there's a daemon set that should be scheduled on that node, and then new API service can be brought up on it. So also if one of your master nodes for some reason had your API server killed, then maybe another API server from another node is going to see like, hey, this node should have this daemon set running, but it's not currently running, so it's going to restart it. Yeah, I'm sure there's a lot of stuff in here, but I'm sure there's some kind of like hosts. Yeah, here we go. So there's like a node selector that tells you like only run API server on your master nodes. And if you compare this file to what we internally use in Rancher to deploy Kubernetes, they're actually very, very similar. So this one is just in Docker Compose format, and you can actually see like a kubelet here, and then all the other services as well. So they're very, very similar solutions. The biggest difference is that in the self-hosted one, you are reliant on your own cluster for making sure your cluster's up, which is kind of a weird state, which is why I love this next image.
Yeah.
So it looks like really nice and clean, and then you go kick one of them, and then it's kind of hard to get back in this state. So what the Rancher way of doing it is you set up one HA Rancher installation, and then past that point, Rancher can manage all of the components for like n number of Kubernetes clusters. So it's like a one-time cost, and then for each of those clusters after that, you don't have to rely on itself, the availability of itself to manage itself. But I'm not sure how much in production you'd actually hit issues where self-hosted Kubernetes would fall flat on its face. I think you'd really have to have some kind of weird scenario where like every one of a certain controller dies, and then it can't bring itself back up. So I guess just time will tell like how well this solution works in practice, but I think it's a pretty promising solution though.
How do you, maybe you're going to get to this, but how do you address the question of upgrades to Kubernetes itself?
I think in both scenarios, in self-hosted and in Rancher, the idea is they're upgraded as you would any other container. So you create a new one and you destroy the old one. Everything in Kubernetes is immutable. Actually, this is an important point. I should have this in the slide. Everything in Kubernetes is stateless except for etcd. So anything else you can kill and bring up again, and then it's as if that piece never went down. So there's like no state stored on disk or anything.
Okay.
So that's why upgrading those components is actually fairly straightforward. etcd is a little bit trickier. We kind of have some fancy one-off logic within our orchestration system to handle etcd, which is actually very similar to what CoreOS did with the etcd operator. It's basically like there's no construct in either Kubernetes or Cattle that matches how you deploy etcd very well. It's kind of a very special service. So like if you look at like all the different Kubernetes types of deployments, like deployments or stateful sets, they just don't work for etcd very well, which is why you have an operator which is basically like a mini orchestration system that manages one thing. But I think operator is like a whole nother talk, and I'm not going to really get into that. So the last option for deploying Kubernetes as containers is actually really, really new, but I thought I'd mention it because I'm sure some people here have like heard of Linux Kit and InfraKit, and you're probably wondering like, what the hell do these actually do? So I was going to discuss like how using these two pieces or these two tools you deploy Kubernetes, which if you look, like they're kind of actually working on this. So they're building like these OS images that you can use to boot and control Kubernetes. So let me go back and like describe these two tools. So Linux Kit is a way of building an OS image that only runs containers. So let's say you wanted to make an AMI or some kind of like OS image that only does one thing. Let's say boots up Redis in a container and that's it. Then you could describe your whole image this way. So you can say like, I want this kernel version.
Hey Josh, can you blow up the font on that?
Yes, yeah, that's a good idea.
Thank you.
Yeah. So you like describe like which kernel you want, like which command line parameters you want. Basically, you can declaratively define everything you want from like an OS image, and then it would go and it would build this OS image for you, and then spit out whatever type you want, whether it's AMI or VMDK or whatever. But the catch here is that Linux Kit builds an immutable asset, which means when you boot this, you're going to get Redis 3.0.7 outline, and then that's what you get forever. And then so like the upgrade model of Linux Kit is not the standard container one where you delete one container and you create another container, possibly in the same node, possibly another one. The way you do it here is you actually like don't run that OS anymore. You just boot another image and kill the old one off. Well, then it's like doesn't fall under the category of container orchestration, so you kind of need another system to manage that upgrade process. And that's kind of where InfraKit comes in. So InfraKit actually will take, like let's say you had a Kubernetes deployment where you run like all your master nodes. It's actually going to go and create a new node, run all the new services in a new OS image, and then it's going to slowly kill off the old ones. And so when you're dealing with this, OS images are more cloud provider specific than containers are. So InfraKit is much more tied to like AWS and like the particular infrastructure that you're running on. So I think there's actually a lot of downsides to this approach. Like I think in general, I'm not a big fan of LinuxKit, but it requires dealing with OS images, which is in some ways kind of a step backwards from containers. So if you were deploying like an immutable OS image, the fact that you're using containers here is almost irrelevant, right? I mean, you could use Packer and systemd to run all these services, and then you can deploy that, and it's pretty much the same thing. So it's like you're using like 10% of containers, and then all the other advantages that are there, you're kind of not using. So it's like 2 steps forwards and 1 step back on containers. And then it requires this whole new tool called InfraKit built that has all these plugins that are like one-off logic for all these different cloud providers and like all these different installation methods. Not to mention, the process of deleting and adding a node is kind of a heavyweight operation. Deleting and running containers is a pretty fast thing. Deploying the image is actually very fast. Whereas deploying a whole new node is like, again, it's like that's like one thing why people like containers, right? You know, it's a slow operation. And for bare metal deployments, that means you kind of have to have some kind of like system set up for running, like bringing up new machines, like rather than just having like a fixed number of machines, maybe for some deployments, and then you could just run containers on top of them. So there's a lot of disadvantages to using this method. I mean, I think for certain use cases, I'm sure it would be really nice. It sounds as if Docker Cloud at AWS is still kind of using this technology under the hood. So I mean, you know, maybe it could work in some cases, but I think it just seems like a step backwards. Then lastly, there are a lot of solutions out there where you don't really need to know so much about what's actually being done under the scenes. You know there are being Kubernetes components being deployed somewhere, but you're not sure of the particulars of how they're being deployed. So there's ones that it's kind of weird, we're partially managed, like Azure Container Service and StackPoint Cloud, where they actually go and provision the master node for you, and then they set up the components on top of that. So you still have full access to these machines, and to some extent, as long as you can log into that machine, a little bit of the maintenance is kind of pushed on you. And there are also solutions out there where you have zero access to the machine. So if you use GKE, for example, I'm pretty sure there's like absolutely no way that you could access the master components. So if you like use gcloud to provision the kubeconfig, which just tells you how to access the Kubernetes cluster, you can see they give you an endpoint here, but I don't really have any way of actually knowing what's running behind the scenes. This is probably just some GCE load balancer here. Okay, so that's all I have. I didn't really have slides and demos and stuff. If there are any other questions, I'm sure I could talk about some other topics here. If there's anything you guys are curious about? Yeah.
Are you going to share your slides?
Yeah, I can share the slides. I can share, that's actually about all I have, so I can share the slides.
I can really say one use case I have for like LinuxKit and all that we're using. Simply a syslog is completely immutable, much more secure. It's one that's single purpose.
Mm-hmm. Yeah, there are definitely, actually, as a tool, I really like LinuxKit. I think it's like the philosophy that I don't like of using like
LinuxKit for infrastructure.
Yes, yeah. I really like Linux. I think the UX is pretty cool. It's really fun to play with. I think it'd be cool if like what LinuxKit did for like non-specialized use cases is basically bring up one thing that connects to an orchestration system. So I think Kubelet is a bad example because Kubelet's kind of versioned, right? So if all it did was start some service that basically pings like an API server and dynamically determine which Kubelet version it should be running, that would be kind of cool because then things are like more dynamic.
Well, people have been for like little IoT device type things.
Yeah, that's what, like, yeah. I think Internet of Things is another really cool use case of it.
The LinuxKit team, I think, is like a unikernels team.
Yeah,
Unikernels were the big thing coming soon for a long time, so I guess their time has come.
You can see like the UX of it is very unikernel-like, which I've never really got them. I've always thought like, why do you want to? I never really understood unikernels, but that could be why I don't like LinuxKit. Yeah.
So I may have missed this because I got here late, but it seems like LinuxKit is very much like CloudFormation. Are they playing the same role, or do you feel like those other tools are either higher or lower from LinuxKit and InfraKit?
I would say it's more like Packer, InfraKit, and CloudFormation. I would say are almost similar.
Okay.
But I would say I'm not sure if the way you do an InfraKit is like you can have a plugin for CloudFormation, and then that's how you interact with AWS.
Okay.
So I'm not sure if they're like strictly competing or if you actually just reuse CloudFormation within the InfraKit.
So maybe launch or Linux Kit is more like a launch configuration in AWS?
Have you used Packer before?
I have, yeah.
Yeah, I mean, it's really like Packer. Like if you
Okay.
wanted to build an image that just boots up and then runs some immutable thing,
Right.
it's like that, but rather than setting up everything at the host level, you
Right.
just define like, what container you want, and then when it boots up, it just runs those containers.
Right.
So I think if you were like doing immutable infrastructure like that, like maybe it has some advantages. It's probably a lot better UX to go and build each of those services individually as containers and then pack them all together, rather than doing like all at once. I mean, it's probably a matter of preference, but it's a pretty similar idea.
Talk a little bit about HA. You know, people talk about HA Kubernetes deployments, and they talk about making the master setup HA. But for the apps to be HA, you know, you'd have to have nodes running in different data centers, or
Yeah. That was kind of out of the scope of this, although I didn't. When you're deploying master setups, I think you want to deploy those also across data centers, but that's pretty complicated. But yeah, it's something you could do. I think like federation, all that would be like a whole other talk.
Yeah,
Like,
plus
there's like a whole
yeah. Plus, it really does seem complicated. I mean, it's tricky, I think, to get it right.
So, with Rancher, when you're actually, like, I mean, not just I just played with the demo thing on AWS. You're launching a single instance that's actually then running Rancher that has the orchestration to run Kubernetes underneath it, right?
Right.
So if that instance is down, then like everything else is still running, but you'll have to run. There's not. Is there? Like, how do you get? I didn't see. Maybe it's in documentation somewhere else, but how to run Rancher in a more highly available fashion.
It is in the back. That's Galera, and you set up a MySQL cluster in the background. You have multiple masters talking to that Galera cluster, and
Okay.
you load balance across.
All right, that's cool.
Yeah, exactly.
It's literally that easy. It's literally like a minute and a half when you set it all up.
Yeah, more like a week and a half.
Super.
More like as you watch my eye twitch when it comes to Galera partition failures.
This is actually something we debate about a lot internally, and it's, would people rather have an HA MySQL to set up, or would they rather have HA etcd to set up?
Oh, I would so want etcd all over.
That's actually like really good feedback, because like we think, well, a lot of cloud services have like RDS built in, so people who are deploying like AWS might want to just use that. So there's no good like hosted etcd services out there yet. So that's one of the reasons why we're still like on MySQL, but we're definitely considering other ways of doing it. Like, isn't MySQL what's the main pain point of deploying HA Rancher?
So when one of the Rancher masters goes down, sorry, let me rephrase. When all the Rancher masters go down, just say like a power failure, or maybe our systems die, and then they come back up, and they come back up at the same time, and they try to run migrations all at the same time, and then it corrupts the database. And what was the solution? I don't even remember, honestly. Create MySQL. Oh yeah, I was going to say from backup?
No, we don't have backups here.
In this case, it was like brand new. So it was just like, and then what winds up happening too is you get cascading this Java errors on every single one. It's like, I can't really write. So I'm going to stay up, I'm not going to restart. So then you actually have to turn them all off and then turn one on. Okay, it will run the migration and then like stagger them. But in the use case, rather the scenario we had, yeah, we broke it hard like 3 times.
That's interesting. Like, the feedback that I usually get is not like that HA is the biggest pain point of Rancher. It's like usually some other people hate it.
Oh, networking.
Don't get me started on networking.
Yeah.
That's the one that people hate.
I ran to
Is not at all happy. Well, I don't know. It's supposed to be happier now, so I haven't tried this lately. But I've seen exactly the same scenario with etcd where.
Oh, when we were bootstrapping Kubernetes in 2014, we literally pulled our hair out several times. It still hasn't grown back because etcd would corrupt, and we would just not know how to fix it. So we'd have to tear everything down and bring it back up. It's gotten a lot better.
Our approach was just to build a new cluster,
That's how people do upgrades.
migrate things over, and then throw away the old one. There was no way.
Just take the forklift out, move it all up, dump it in the trash. Or...
No, there was a manual way apparently to recover, and I think I tried it once, but it was many, many hours and it's still, we didn't have any faith in it, so.
Well, you
right
can
now,
jump
it's
into
still
the-
new.
Yeah, go ahead and jump in.
Yeah.
We need an FSTK for clusters. Someone needs to build that, so get on it, okay? The slides will be shared. We're actually gonna jump in chat now with the CEO of Fly.io, a new service based out of Chicago, ensuring application delivery without you having to worry about ingress at all. I think we have Kurt in there, and Josh is gonna set it up and
Yeah,
get
it
this
should,
going.
should be out of these speakers, I think.
Okay, make sure.
He's gonna get it. Can you hear us, Kurt?
I can, you hear me?
Cool.
Hey,
Yeah,
it's
Kurt.
almost like he's in the room.
Oh my gosh, that's crazy. Can you hear us, Kurt? Okay.
I can.
Awesome, awesome. Well, I'm Mario Loria, and the guy whose laptop you're on right now is Josh Curl. This is the Orchestructure Meetup group, and there's a bunch of eager people here waiting to hear you talk, and then they're gonna swarm all the shirts and free stuff they can get that I put at the back of the thing. Actually, here,
Should I turn the camera
Can I-
towards us?
there we go. That's me. I'm right here. Can you see me? So go ahead with your spiel.
Yes. Nice wall. Hey guys, we're happy to be sponsoring a cool group like yours. We've been, I actually know a couple of you, which is really strange. But we're based in Chicago. We've been doing church for orchestration for a really long time across a couple of companies. My last company was called Compose. It was previously Mongo HQ. It's been Ars Technica, which is bought by Condé Nast, which is how I probably know some of you. But now we're basically building, depending on who we're talking to, what we're calling an application delivery network, which is, you can kind of think of it as CDN 2.0. And one of our big theses here is that you should actually target a lot of development of the proxy, because there's a lot of product and feature problems that you can solve at the proxy level. Keep things fast, keep things more secure. And I think you guys are talking about Kubernetes today, right?
Correct.
Yeah. Did I read that right? Anyway, we tend to work really well with Kubernetes, and one of the things we'll probably hear about is basically turning up apps and pods. And as a seamless integration, you use Fly with apps and pods. Because basically you add our little agent to any web process that connects to our global network of proxies, and then serves up your traffic. And you can skip all the weird ingress stuff that's kind of hard to configure if you want. So, Gary, what you guys are doing, and if you ever need any help with traffic distribution or want to speed things up, come talk to us.
Yeah,
And enjoy the t-shirts. See you guys.
Yep. Cool. Yeah, they've got a Slack channel, and I can send you details on getting in that and talking to Kurt directly. He's always in there. So there's some free shirts from Fly that were sent over and stickers in the back. So don't all rush right now. We'll get some afterward. But if you guys have any questions, it sounds like he can hear us pretty okay. So if anyone wants to ask questions, he's seriously talking about taking away everything that you've heard about with the pain points of starting an ingress controller or ingress rules in Kubernetes and running your application delivery semantics with the application itself. So that's what we're talking about here. And then you use Fly's interface. I believe they have an API as well to manage these rules. So you're kind of taking away the application, the back end, and the front end, and the front end is all handled with Fly, and you just manage the back end, right? So that's exactly what we're talking about. We're talking about all sorts of redirect rules. If you want /cd to go to a different site, whatever you want to do, you can do it with their platform, and it works really well. I've used it, so.
I have a question.
Shoot, yeah, go ahead.
Does your platform support regular expressions in the URIs?
It does, except the way we've exposed it right now is closer to like the Rails style routing parameters.
Okay.
And so you can do a Rails pattern, and basically, we have a couple of people doing that actually, and what they do is they send a certain pattern to one particular application, and then every other bit of traffic goes to a different application. Other cool stuff we can do much here, but we also, we're session aware, so we can actually tell if people are logged in or not. So if you go to Fly.io and you've never signed up, you actually get a GitHub Pages app every run. You get our Rails app. So there's a fair amount of logic for how to direct content to the back end there.
Awesome.
Request.
Good, George.
Hey Kurt, I don't know if you remember me. It's George Castro.
How's it going?
Yeah, I was reading the Ars Technica's article when you guys first launched, and it compares you to Cloudflare. but I think you also sound a lot like Fastly. Could you kind of tell me where you fit in that world? What am I mixing up there?
Yeah, I think I heard most of your question. Basically, how we fit between Cloudflare and Fastly.
Yeah,
that's
exactly. Because ours kind of only mentions Cloudflare, but a lot of your edge stuff sounds Fastly-ish to me.
Yeah, and actually Akamai's in there too. And although Akamai is incredibly painful to buy stuff from, they deal with a lot of this stuff too. Fastly, we keep running into with like media companies. Because Fastly you can kind of think of as, I mean, they're going to do a lot more than this, obviously. But a very simplistic version of Fastly is they run a hosted varnish setup. And so they're kind of all about caching. Good with like the VCL, the varnish config language, which I'm unfortunately pretty good at. You can do some of the stuff we're talking about. So you could actually do things like route different parameters, different mechanisms of varnish, and thus Fastly. What we're actually trying to do is make it a lot more developer friendly and make it a lot more integrated with an app. So like you can't with Fastly, for example, read a session, change how you serve content to log in users and not log in users. And so it's like it's kind of interesting. The other thing, and this isn't something we show on our website yet, one of the things we keep hearing from bigger customers is actually a lot of people don't really know if they want a third-party CDN. They'd actually rather run their own edge. And so we're talking to some larger people about deploying Fly on servers using something like, I'm not sure how familiar you guys are with like Packet.net, but Packet.
Yeah, I'm here.
API-driven physical service. What, is everyone familiar with Packet?
No, Kurt, we actually have someone that works at Packet here in the crowd.
Packet. Yeah, so we've talked to Packet a lot. Very New Yorky. Anyway, so yeah, Packet's cool for that because Packet's kind of solving the how do I get code to the edge problem. And we kind of want to be the software component of that. And actually, the interesting, I think, Varnish, there's a piece of software called Varnish Pro. If you want to run your own CDN, that's the place you start. I think I tend to compare us more to that because what that is like a CDN plus. So yeah, basically, like I tell people to use Fastly for static files and use us for your dynamic content. And I think that's probably the easiest way to think about that.
Cool, thanks. Any other questions?
No problem. I see you.
Yeah, so we use Fastly in the front end, and then we actually use Netflix Zool to allow our developers to have to control the routing. We have fairly tremendous amounts of varnish, but it's difficult for the developers to find that as accessible. It's also difficult for us to test it and to have good regression safety. So we've been using Zool, but even that is actually starting to show its limits. I work for Ithaca, JSTOR, the academic journal company, but so we've been exploring other alternatives like Kong, and you know, some of these other things as we're trying to. We have a very heterogeneous environment, so you can kind of alphabet soup whatever technology, and we probably have it running.
Kong's really good for API, so if you're trying to deliver an API, they're better than us. We're more of the application side. Well, depending on what you want to do. And so yeah, check us out. I'm curious if what we do is actually solving some of the pain you feel. Like I'd really love to know. We're only like 7 months into this, so we're actually still kind of finding our way and learning what matters most. But we have a real, like I'm still a developer, and in fact I spend way more time developing than I do selling stuff, but we're really interested in kind of solving problems bottoms up for developers. And ultimately, like when you have this concept of edge middleware, what we'd really like to get to is where you developers of our service could run their own code at the edge or on requests and make it like a really extensible version of all the stuff that's currently out there.
That'd be awesome.
Cool. All right, check it out. Thanks.
All right, we'll take one more question. If anyone has one. No. I think we're good. Kurt, I think that's about it. I have your email, which I can share with the people here. I can get them in the Slack chat. Let me know if there's any other communication mediums you want me to connect them with.
Yeah, email Slack.
Okay. Alrighty.
So yeah, if you feel like signing up. Also, we have a huge free tier, so like you can go play around without that.
Yep. Yeah. Automatic HTTPS. It's pretty awesome. All right, thanks a lot, Kurt. We'll talk soon.
Yeah.
Have a good one.
Talk to you all later.
Yep, thanks.
Thanks,
Bye-bye.
Jared.
So, yeah, so there's some stickers and shirts, some flat stuff that was sent to me. It looks like Josh
Yeah.
also brought some rancher.
I don't have too many shirts. I have 4. I think they're just medium and large. But I do have lots of stickers and
You-
3 foam caps.
Four shirts. Did you say 4?
4?
4 shirts, like
Yes.
keep them on yourself. Very cool. I like the stickers, nice. That's all from me officially, so talk amongst yourselves, ask Josh questions, and get more pizza. Thanks, guys.